Today we will be working on environmental indices, and I'm going to use Landsat for a case study. First and foremost, I just downloaded the Landsat here, and from what you can see here, this is Landsat 9, level 1, then which is in part 172 through 62, and then this was acquired on the 1st of September 2025. Now it's in zip folder, and this is my ArcGIS, so I just save it as environmental indices. And what I just need to do is it's in a zip folder, so I'll click here and I can right click, and this is extract, so I can extract this. So I'll go ahead and click extract, and that's going to unzip this for me, and that's done. Then if I open up this folder, you can see the series of the Landsat imagery here. Then I'll return back to my ArcGIS. I can use my catalog, which I can click here, and I can also navigate to the folder or the directory where all this is. So you see here, this is the location. Then I can as well connect another folder by also going here to go to my desktop if I want to connect the folder, because you see now that the folder is not connected. So I can just go to the entire folder here, and maybe I can choose to connect this entire folder because I want it to be something I can see under folder connection here. So by doing that, so you can see here that I have page 25 here, and if I go to data, you can see the data here. And if I go to satellite, because I save it in satellite folder, and you can see the Landsat zip here. Then down here, if I drag this a bit for you to see well, so you can see the different band, which is exactly what I am seeing from here. So the same thing is here. Now, a quick one. If you go to band combination, like I was trying to say before, so if you go to band combination of Landsat 8, you will realize this particular important information. So I like using GIS geography in this because it actually put it well. So if you see here, you see we have different band here, from band 1 band to band 11, and all these bands are of different band. Now if you go down here, this is for band Landsat 8. So what it means is that if I want to see the natural imaging, I'm going to have a composite of 4, 3, 2. So in that way, this is just like a bit of explaining to you. So I'll go ahead to return back to the same catalog here, and you can see here that I have band. I can choose to combine all the band from band 1 to band 11, all of them. I can choose to do that. Or if I just need the natural color, I can only choose to combine band 4 and then band 3. So what I mean is, as you see this, I can just drag and drop here, and I have added band 3, band 4 and band 2 to it. So by here, you see all these ones here. So I can drag and add. I can also right click, and then I can also add this one into it. So whichever way you want to put it here, that's also fine. So most important thing is to bring in the imagery here. So you can see here is asking me, do you want to calculate the statistics? I'll go ahead and say yes, and that's going to do the statistics, and so I'm bringing the data here. So I can do this for all of them. I can click on the choice and say yes, that I want that to happen. So whichever way, that's going to add the imagery for me. So you can see the 4, 3, 2 have been added here, and by looking at it, this is what it looks like. But because it is still in different bands, so you won't be able to actually see it in natural color. So for me, if I want to see it in natural color, so I will do what we call band composite. So band composite is a process of bringing this band to form a single raster. So you can see this is the image I download, and it is over Rwanda, because if I overload this street on it, so you can see part of the Rwanda here. That is this is the part that it is in Rwanda. So the rest of the part I think is in Burundi. Now Because of band composite, you won't be able to see it naturally, so you can see the way it looks. So in my case, if you are here, if you go to raster layer here, so this is raster layer. If you go to imagery, you can see these different functions here. So for me, I just want to make a quick one. So this is raster function. So if you click on raster function, that's going to open this function here for you. So you have different aspects of raster function here, rest of them. So from analysis down to appearance, down to classification, down to conversion, down to correction, data management, math, hydrology, math condition, math logical, reclassify, SAR, that is sentinel radar aperture statistics, surface. So like, this is where we're using when we're talking about contour. So you can see everything that have to do with raster here. This is what it is. So from here, I can go up to analysis here. Under analysis here, so you can see here that we have order this from binary threshold, change detection, generate trend, land trend analysis, NDVI, NDVI custom colorize, and rest of them. So in here, so you can see different aspect of raster that we have here. So you can also do composite. So now this is here. Then if you go to processing here, you can see here you have composite. Now a composite is combining multiple data sets into one data set. So for me, I'll click on it, and when I click on composite, I want to merge all these things, because if you look here, what I explained earlier, you can see what I mean. If you want to have a natural color, you need to do 4-3-2, that is the band combination. So if I want to make a composite, so if I go ahead and click on this composite, and that should be able to give me the to bring in the composite for me, so I'll be able to make a composite. Now there are other things you will need to do, something like you can do pre-processing depending on what you are doing. So if it is pre-processing, you can choose to make your pre-processing in the sense that you, depending on the imagery, so you can do pre-processing on it, like making a atmospheric correction, radiometric correction, depending on them, either using any other software like MV, or you can use ArcGIS, or you can also use ELDAS image. So depending on them, to do radiometric correction, like atmospheric correction or geometric. So any of those things can also be done on the imagery, but that's not what I want us to look at now. So I just want us to like completely look at the aspect of the band composite. So in my case, I have added the data here under processing here. So if you click on the composite, so that brings you to the composite. Now the difference between composite and mosaicing, we are going to talk about it. The difference between composite and mosaicing is composite is to bring the bands, different bands, stack them together, while mosaicing is the process of assembling them. Like if you look here, you see now that the entire band that I have did not cover Rwanda. What if I want to do analysis of the Eastern Province, for example? You can see now that I need to download another image. So for me to bring this imagery as a single band, so in that way, I will need to use the band composite. I need to use the mosaic here, and it is the mosaic that is going to bring them together for me. Now, the same way, the same thing apply to composite. Composite brings the different image and stack them, so the different image will be in the same place and you bring them together, while the mosaic is on different place, like you have another tiles here, and mosaic will bring them to form a single raster for you. So this is composite. Also, if you go to ArcGIS, so let's go to geoprocessing here, and then if you go down here, and if you go straight to raster, so data management tools, which is here, and then you go straight to raster. So I'm looking for raster. My mouse is a bit malfunctioning, so I wanted to like explain what I was doing before, but you can go here. If you go to raster processing here, you can see composite as well here. So the same way you see it under there, so you can also follow the arc toolbox to get that as well done, to see it there. So for me, if you want to make a band composite, so you can see here I have band 4, then this is band 4, and then I can select. You can see this is band composite output. Then another one here I have band 3. Then you can see this one here I have band 2. So I have added band 3, so I can also add band 2. So you can see the raster composite here. So this is the output or the location that is going to come. So I can also like reduce the length. So let me just do like this. So I can also run it from here. So if I go ahead, I can run, and you can see that we are on the band composite. So as I will use the imagery part that I showed you earlier. So if you make band composite, that's going to make the band composite for you. So you can see here, and it is actually working, it's saving. So once it finish, so you will be able to have the output here. So now what does it mean? So it have stacked those imagery of different layer, and at the end of the day you will be able to have one single imagery. And if you have one single imagery, so what it means is that you are going to have an output that is either showing you the natural color like I shared with you on, or I shared with you here on this site, that if you make 432, so you are going to have natural color infrared. So this one replicate what human eye see. While healthy vegetation is green and unhealthy flora is brown, urban area appear to be white, and then gray, and water is dark blue or black. So here, if it is color infrared, so you can see what the combination gives you. If it's shortwave, if you're looking at agriculture, you do 652. If you're looking at geology, you do 762. Bathymetry 431. NDVI, so which is why we are here today. So when you do this, if you look at the image I have, you see before I had this. So let me uncheck this. Before I had this. Now this is band 4. Look at band 3. This is band 2, as you're seeing. But now I made a composite 432, and you can see the natural color here. So let me uncheck this. So if I uncheck this, yeah, the districts is what I'm supposed to uncheck. So if I uncheck this, so you can see the natural color, as you can see it here. So this has given me the natural color. So over here now, so you can see the natural color. So remember what I said earlier about band processing. So when you put it up like this, by combining this is actually going to give you the right color you see that you're supposed to see here. Now this is also raster. If you click on this, so you can also, like, this is DRA. Then why I select this, so I can click on DRA, and then this is also going to stretch the image to look better for me. So you can see here that this is the output of the file by making band composite. So it's actually now giving me the right color here. The natural color, what to replicate human eyes, and what human eyes can see is what I'm having here. So with this, you can proceed with different analysis that you want to do. Either you want to do land use, land cover, which we are going to do. So this should be able to get that done for you. So that's the way you can do band composite and then get it done. So this DRA helps you like check how the imagery looks. So if you look here, if I check it, you can see what it looks. And we have been talking about resampling, the resampling, so which we talked about a bit before. Now that's not why I just want to show you like the way you can make a band composite. But in my own case, as you can see here, if I want to add all the imagery, like I said, I can add it from the catalog, or I can go to home here, and then I can click on this. If I go to the same directory where I have the Landsat imagery, so I can just decide to paste the link I copied here. I think I didn't copy it. So from here now, I can also add it. So whichever way you choose to add it is on you. So if you still go here and press enter, and that takes me. So you can see here that all the images that I have in that folder is also here. So I can choose to also select them and add them here. So you can see them here from number 1 to number 9 and rest of them. So in this case, for the sake of this, I'm just going to add all of them. So I'm going to pick it from 1, and then I'm going to go through 11 here. So hold shift and then select all the 11, and I'm going to click OK. Then it is going to ask me, do you want to build a statistic? And I will say yes. So that's going to happen for me. So if you click yes, that goes on. So if you don't want this to be showing again, you can go ahead and click always use this choice, so that this is not going to repeat this same question is asking you when it comes to calculating the statistics. But if you want your system to be interacting with you, you can always leave it like that, so that you will not sleep on your PC, so that will keep you busy. But if you don't need it, just go ahead and check. Always use this choice, and you don't need to repeat that next time. So it's just going to bring that up for you every time you click on it. So for this case, because I'm not going to talk about band composite again when we'll be doing land use, land cover, so I will just assume that you have already understand these processes of band composite, so there will be no need for me coming up to start repeating the same thing over and over again. But I will just assume that you already understand what I said. So if you look here, I'm going to go down a bit to remove the rest of the things we have been using. So here down to here is what we had imported earlier, so I'm going to remove. Now if you look here, you see now that this is how the different band looks. This is band 11, this is how it looks. This is band 10, this is how it looks. This is band, you can see the variation. This is band 9, this is the nature of how band 9 looks. So all these bands have their different functions and the reason why they band. So some are there to acquire in infrared, some are there in visible regions, some are there in shortwave, depending on the visible, depending on the different spectrum. So all these bands you can see here are of different types, so which you can get. So in my own case, I just want to make a composite because I just wanted to know how to do band composite. So I'm going to check all of them, so which you can see that all the band that I have here is checked on, so that you can take your time to visualize how different all of them looks. Like I said earlier, under the imagery you can see processing here under the imagery. So if you have any of them here selected, you can see the processing is activated. So if you go here and select from the first one to the last one, so you can see all of them are, or you can see this activated. As I always say, you can go to geoprocessing here, which is where I was. So if I want to make processing composite as well, so I will just go here. If I select here, I can start from band 1. So this is band 1. I open up again, I will say band 2. Then I open up this thing, I will say band 3. Then open up here, I will select band 4. Open here, I will select band 5. Here, I will select band 6. Then here, I'll select band 7. I'm doing this because I want it to be in alphabetical order. Then here, I'll select band 8. Then here, I'll select band 9. Then next one, I'll select band 10. And then here, I'm going to select band 11. So let me closely watch. You see band 1, 2. I miss band 3. So we miss out band 3. So let's go for band 3. So you see you have band 3. So for me, we have band 3, so I want to arrange it in alphabetical order. So for the sake of this, I'm just going to remove this because I wanted to arrange it in alphabetical order, so that when I was expansion I want to make later, but I just want to make sure it's in alphabetical order. So this is band 2. So let me go here, band 3. Yes, so here band 4. Then here is band 5. Here is band 6. Here is band 7. Here is band 8. Here band 9. Here 10. Here 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now remember what I said before when we were downloading satellite imagery. I said you can go and choose the band you want to use independently. I can choose 432 only and download from USGS to use for what I want, but I just want to show you this. So on this, I'm going to run the composite again to replace it with what I have done before, but it is saving. So I want to explain this thing. So I want to explain something, and that's the reason why I am making this. What I want to explain is exactly what I have here when I say band composition combination. So if you combine this, this is what you will see. If you combine this, This is another thing you see. So I will just show you how you can combine to get the natural color. How do you combine to get infrared? How do you combine to get shortwave? How do you combine to get for agriculture, which is combining 562? So that's just what I wanted to show, and that's the reason why I am trying to combine all of them, because I want to change that at every given time to be able to show you how it shows. While we are waiting for it to finish, I'm going to jump to something else. So I just want to take few of the 3 environmental indices. We have many of them. If you remember, I shared a screenshot on WhatsApp that have different band combination and the application. So that was shared to give you the hint of what we are going to do today. Now, when you're talking about NDVI, we're going to work on 3 different aspects. Number 1 is NDVI, NDWI, and NDMI, for example. Now, for you to calculate this, it is different from satellite. So since I'm using Landsat, I have to use this because the band for Landsat might be different from Sentinel. So the formula are different. So what I mean by formula is that maybe the near infrared for Sentinel is maybe band 8, whereas for Landsat is band 4. That's what I mean by different band. So for us to get the NDVI, which we use called normalized vegetation index, the purpose is to measure the vegetation healthiness and greenness. The formula is NDVI is near infrared minus red all over near infrared plus red, which is the near infrared, which is band 5 and band 4. Then in ArcGIS calculator, you can calculate it here, this, which is what we're going to use. Then when you talk about NDWI, it is normalized difference water index. This is Mark Fitter version. So in this one, we use to dictate water bodies, and the formula is green minus near infrared, green plus near infrared. You use band 3 and band 5 in doing NDWI. Then we are also going to use the NDMI, which is normalized difference moisture index. This is to assess the vegetation moisture content. Now we are going to be using NDMI, which is near infrared minus the band 6 and then near infrared plus band 6. In raster calculator, we are going to use this. So in calculating this, we are just going to get these 3 done. There are several of them. If you look at what I shared on WhatsApp, you can see we have many of them and its application. So we have endless of them. So many of them can be used for different purposes. So I just want us to pick these 3 at any place you pick, and then we are going to pick these 3 to make a few analysis on them. Now on that, I don't know whether it is done, but yes, I just believe it is done. So because this has been completely done, like you can see it here, I am going to scroll here to remove this imagery down. I'm just holding shift, right click on all of them, and I'm going to click on remove. Now when I click on remove, I'm only left with 1 satellite image. So let me save it before the ArcGIS change mind. Now a quick one, you can see the look here. This is what it looks like. Now for us to get to change the bands, you can right click here on this. If you right click here, this already picked for you. Now, or you go to right click here and go to properties. When you go to properties, you go to when you go to properties, so you can change the way you want it to eat the bands to visual. So you can see this is the name here, this is the metadata here, then this is the source that shows you how each of those data. This is if they have elevation. Now this is display, this is here, this is join, and this is regular raster. So this is what have to do with the properties of this particular raster. So everything have to do with source comes here. This is the raster information here that gives you information about the raster, the size, the level. This is the band metadata here. You can get band 1, band 2, so you can get information about each of the band here. Now statistics here, extent and spatial reference here. So this is the property about this, everything you done. But if you right click here, you can see here that I have band 1 to band 11, and this is what I wanted us to stick here. Assuming I need to have natural color, I will change this to 4 RGB G. I will right click on this as well here. On the green version, I will right click on it. It's supposed to be 3. I will select 3, so you can see the way it is changing. Then another thing is 2, which is RGB. So I'm going to right click here on the band here, and I'm going to put this one on band 2. Sorry, I think my mouse is having a bit issue. So I can now right click and go to band 2. So I'm going to RGB. Now if you put it in 432 like I explained earlier, then it is going to show you in natural color. The natural color I mean is that it is going to change to natural color, meaning that it's reflective. So if you look at this imagery now, it is showing you natural color, which exactly replicate what I shared with you here. It is now in 432, and then this is R4G3 blue 2 gives you natural color. So if I want to look at it in the aspect of agriculture, and I'm going to make it RGB is going to be 652. So in this part, I will return back to ArcGIS. This is already in 2, but this one says for us to see it in agricultural distance, so it's going to be 652. So let's change, right click here as well, and then we'll put it in 6, and then we'll put the green version in 5. So that's what it means here. So here, why we put this one 652. So I will right click on this, and then I'll go to 5, and that's going to show us this is 652 based on what we have here. So the display is going to be in agriculture, so which is commonly used for crop monitoring, because the shortwave and near infrared, the healthy vegetation shows dark green, but the bare soil has a magenta color. So let's return back to ArcGIS, so you can see here this is what it shows based on the agriculture. So you can see these colors and replicate what is. So if you're interested also in let's go here. If you're interested in pancometric here, sorry, not pancometric. If you're interested in bathymetry that have to do with water, so you have to use 431. That is here. So if you're interested in that, so let's go to 431. So you also do the same thing here. So you right click and select 4, and then you go to this one, that is green band is going to be 3. So we go to 3, and then the blue band now is going to be 1. So I'm going to right click on that. It's still loading. So this goes to 1. So this goes to 1, so I'm going to select 1. So you see 431 replicates exactly what we are talking about when it comes to bathymetry. So which combine 431, and then the coastal band to peek into water, and then the coastal band is useful for coastal bathymetry or aerial study because it reflects the blue region avoid later. The band combination is estimating to suspend. So these are English, so which you can later go on. So this is how you can make changes this, and then you get it done that way. So in this case, I'm just going to leave it in 2 to replicate the natural color or what human eye see. So this is the way you make your band composite, and then you can change the combination in that pattern. So this is done. Now, how do we calculate the NDVI? Now, I'm just going to calculate the NDVI using the raster layer. You see here, we have the imagery layer here. So I can go ahead to change this, and I'm going to start with NDVI. Then on NDVI, I'm going to go to raster function here, and you see here that in the raster function, we have the NDVI here. So this has been fitted in for me, and you can see the bands here. It is in natural color. So I will go ahead to go to NDVI. We have the colorize here, and we have NDVI here. So NDVI, this create a data set representing the vegetation based on the difference between the red, the near infrared, and the negative represent the cloud, water. This, if you look at this, like I said before, anytime you want to see more information on it, hover over it and you get more information. So if you click on this, now it is going to ask you which raster do you want to use. So I will go here to select this band, this layer, and which band represent visible region. The visible region is band 4. So it is the band 4. That's why I have to make it in alphabetical order. Then which one represent the infrared? The infrared is band 5. Where do I pick this thing from? I'm going to return to this I showed with you here. Now, NDVI said near infrared minus red and then this is near infrared plus red. The Landsat 8 uses near infrared band 5 and band 4. Now, which of them is invisible region? Band 4 is invisible region. Which of them is near infrared? Band 5, and that is why I am picking band 4 as visible and band 5 as near infrared. Now, outputting in science, a scientific output means that if you check the scientific output, it's going to give you in decimals like normal way. So if you don't check this, you are likely going to have issue on that. So when you get this done in this pattern, this is NDVI. So I'm going to go ahead to create here to create new layers. Now in creating new layers, I'll wait for it to finish it, and quick, I have the NDVI. So if you look here, you see this NDVI ranges from here to here. Remember, when you hover over it, it says when it is negative. If you read this, it is water body. So if you look here, this represents the water body. So if I don't like the color, I can right click here and then go to the symbology. If you go to the symbology, I want to make it in between red and green, where we have. So if you look through here, you will see between red and green. So let me look for this. So I'm going to use this, and this shows you the so the green part shows where the healthy vegetation. You can see 0.5 here, and here is minus, meaning water body and bed soil. Now I've created the NDVI. Now if I want to create the NDWI, so I am going to use the geoprocessing here, and then in geoprocessing I'll go backward, and I'm going to use raster calculator. So under here, under the raster, so you see here we have here spatial analysis tools. For example, I showed you there, when you go here, it is also here as well. So you can choose to use this raster function. So this is raster function here, so I can get the rest of the information here, but I just want to show you how do you use the raster calculator. So under here, I'm going to go to math algebra. Then in math algebra here, I'm going to go to raster calculator. Then in raster calculator here, so you can see this end here, this comes in here. Then over here, you see that we have this band here. So this is band here. You can see the bands up here. Now in this way, I want to use it independently. So in that way, I am just going to show you how I'm going to use two stones to kill one bird, which is by bringing the other band, because I told you that you can independently download the other imagery without you having to come here to look for it. So now what it means is that I am going to bring in a band 5. This is for NDWI. I'm going to bring in band 3 and band 5. Like I said, you can download what you want to use. So in that way, I'm going to go to map and I'm going to add. Then in adding here, I'm only going to bring band 5 and band 3. So I'm holding control to bring in only these two. So I'm just going to use this as example. So you can see I have band 5 and band 3 here. So in that way, if I return to geoprocessing here, you see this band has been added here for me. Now following this particular function or the formula we have here, which like I said, if you go here, you see now that NDWI, that is not normalized difference water index, is green minus near infrared, and then green plus near infrared. So in that particular pattern, I'm going to encode that into the raster calculator, which is geoprocessing here. Then what I'm going to do is that here, because it is going to be float, so you are going to look here and pick up a float. So you go here until you see float. We have talked about float many times. So the formula says green and near infrared. What is green? 3. So I'm going to double click here. You can see I've added green here. So if you say green, there is a minus here, so you can also put the minus here. So I'll go down here to look for minus because I don't want to type it. So I will double click here, minus, and then band 5, float this minus and 5. So I'm also going to put 5 here. Double click on 5. Then the next thing is over, which is here. So you have to click here to get over. So you can see the over here. Then go ahead again and select float again. So if you look here, you will also see float. So where is float? So I'll go down here to look for float. So you can see float here again. Then the next one is you repeat the same thing, band 3. So band 3 here, double click on it, then plus band 5, double click on plus. No, all of them have to be in the same bracket. So in that way, this is supposed to be in this bracket, not outside. So I'm going to go this. So this is plus sign, double click the plus, and then band 5. Now you can see here that the formula I calculated here is band 4, float band 4 all over float band 5. So this one, as we see, we are going to call it is going to be float, but I'm going to make it here, it is going to be ND. Here it's going to be NDWI for 2025. Now NDWI for 2025, once this is done here, then the next thing is I am going to run this. So this is going to calculate the NDVI for NDWI for 2025. So with this, you will be able to have the output when it finished running. So this is for NDVI, NDWI, and when it is out, so you can see the output here, which is what we have there. So on a quick one, we will also go to calculate for the next one is the moisture content, so where it is called the near infrared and then SDWI. So in this one, we're going to go to near infrared minus the same way, which is 5 minus 6 all over 5 plus 6, the same. This is the formula for it. So if you also return, so that means in this way we already have band 5 here. This is let me expand this a bit. This is band 5, so I'm going to remove this because I don't need it. Then in this way, I'm just going to bring band 6. So I'll go ahead here to look for band 6, select band 6 and add it up here. So you see we have band 5 and band 6 here already. Then I will also use the same geoprocessing to the same thing. So now I am going to remove this from band 3 to band 5. So this way it is band 5 minus band 6. Based on what I showed you here, is band 5 minus band 6. So in this way, so we return back to geoprocessing again, and we can this to clean this or to reformat it. So for my case, I might just use to clean all of them. So highlight and remove, and also start again with float. So I will go down here to look for float. The float is somewhere here, so you can see it here. So I'll double click on it. Then what do I need to use now? I'm going to use the band 5. So this is band 5 here. Double click on it and then minus. Make sure it's within the same bracket. Look for minus sign here. Double click on it, and that comes in here, and then band 6. Then you now go outside the bracket and press all over. Double click on it and then pick up float again. So I'm going to look for float as well to add. So scroll down a bit. This is float, so I'll double click on it, and then I will pick band, also pick band 5 as well. So this is band 5, and then this time put it same brackets, and then this time is going to be plus sign. So I'll go up and pick up the plus sign, and then also plus band 6. So this is band 6. I'll click here. Now here I'm going to change it to NDMI, which is moisture, so it's no more WI. So I'm going to replace this with M, so it will save it in different. So once I finish with this, I can go ahead and run for the moisture content. So now I have 1, 2, 3. So NDVI. Then the next one I have is NDWI, which is water index. Then the last one is what I call the ND with the moisture content. So we have 3 of them here. So on this, I'll go ahead and remove this, and then I'll go ahead and remove this. So in this way, I'll remove this 1, 2, 3. So I have the NDVI, I have the moisture, and then I have the water index. So for water, I'm going to change the color to something else. So let me just go here and select. This is for water, and here this is for moisture. So up here, so I can use a different color altogether, so they can have a different view. So this is it here. So we have these three of them: the moisture, the NDVI, and this. So now if I want to make a study, I can go ahead and make my study. So now I'm going to save this. I can use this to produce the different visualization of the map in the layer like I've showed us before, like the way we do study area. That's left for you, so we can do that. So if you look at this, you will see the different thing about the moisture. They are of different variation. You can see NDVI here, variation. This one also another variation. NDMI also another variation. Now I'm going to overlay the district map on it, and based on this, I will want to make it hollow for one reason, for the sake of this study. So I want to make it hollow. And when you look at this, I'm going to right click on the district, and then I'm going to symbology, and here under this symbology here, I just want to make it single color. Then I want to make it black, and so that you can see the big aspect of it. So in this way, I'm going to return back here. Then you see here that I have 1, 2 districts overlapping with each other. So in my case, I am going to go ahead for the sake of this study. Let me see what the natural color looks like here, here, and here. So I want to check and pick something that will be perfect for the decision I want to make now. So you see, based on the location I downloaded, okay, NDVI selected. This is the natural color. So if you look here, see I have these 2 districts. I don't want to go here because there is a cloud cover here, flare here. I don't want to pick up here, but I want to pick these 2 districts here. I think Bujesera and another district here is what I want to pick. So I can also choose to pick the Bujesera alone. So let me go ahead with only Bujesera. So in this way, I will return back to home here, here, select, and I'm going to select Bujesera. So holding the districts and make my selection. So I'm only going to select Bujesera. So let me uncheck this, and then you can see Bujesera is selected. So in my own case, remember what I said, I can choose to leave it like this now, or I can choose to make it as pretty as a new layer. That's left for you. So but for the sake of this, I'm just going to right click on it and go to selection, and on selection I'm going to make layer from the selected feature, so I can take off the entire district. So I'm only left with Bujesera. Now in here, I'm going to go ahead here to go and do raster. So by clicking on this, then the raster layer is going to come out here. So you can see raster here, like I explained to you before. So you can choose to do mask it. So if I say mask by district, so if you click on district selection here, so you can have your mask here. So if you select this, so that means you need to mask this particular one based on the districts. So if it is this one, so you select that, and that is selected for you. And so I have already masked districts. Yeah, let me moment. Okay, so this is masked by district. Then let's go down to here, and you can also go to imagery, and you can see here that you have is loading. You see here, this is processing. You have clip here, and you have mask here. So you can also use this as well. So when you select that, so you are going to clip it based on that particular layer of choice. So this and this. Okay, so you have this here. At the same time, you can mask them from here, or you can also still go to geoprocessing here and return here. It's just also left for you. Then when you go here, I'm showing this because you can use anywhere, either by using the top here, or you can still go here because it's also necessary you get to know how you can do it from here. Then if you go to if you are under extraction here, you can check extraction and you can do extract by masking. Under extract by masking, if you put in the NDVI 2025 here, if you put in the NDMI 2025, you can also choose to mask it by the district selection. So here, so I can edit it to mask extract 2025 here. So I can run inside is where the extraction area is. Remember, I've explained this before. So I can run this, and that's going to give me the NDVI based on 2025, masking it for only Bugesera. Like I have inputted the district layer and as well as the other layer. So I can only mask it by 2025 for Bugesera. So you can see it here. Now for this one as well, I am going to also select the NDWI. Then in the output here, I am going to change this to W instead of M. So I'm going to change it to W. Inside is where the data is. I'm going to run the second one, and that's going to give me the NDWI for 2025 on this particular place. Yes, then that's going to come up for the NDWI. Then I will also change the parameter to NDVI. NDVI here. No, I can change it. I've done NDWI, so let me go to NDVI. So this is NDVI here. Then I can also change this to, instead of WI, I can change it to VI, which is vegetation index. Then I'm also going to run that as well. So once this is done, my study area now is in Bugesera, and that's why I want to focus on. I only want to focus on Bugesera. So on this note, I'm going to remove the every other data that I don't need there. What are the data I don't need? I don't need the whole or the rest of the data I don't need. So in that case, I'll go down here to click on the band. I don't need the band again. I don't need the main NDVI. I don't need the main this. I don't also need this. So I'm going to right click and remove them. Now by removing this, I'm also already only left with the extract. So I'm also going to remove this mask, the what I tried doing earlier. So I have three of the layer here. The first layer here is the layer of extract of NDVI, extract of NDWI, and extract of NDMI. So all are here. Now I want to just make an analysis on them, on this analysis. So what I'm going to do here is that in here I have each and every one of them. Remember, the NDVI, you can always change the color here. So if you want to make analysis of 2015, so which you are going to do, so you will have to use 2015. If you are choosing 2015, choose 2015 and 2024. Sorry, if you choose this, choose 2015 and then 2025. If you choose 2014, choose 2014 and 2024. So you are going to look at the primary, like for me, my primary target here, you can see the airport. This is the airport here. This is the NDVI of this particular airport. So if you look at it in 2014, or since I'm using 2025, if you look at it in 2015, this airport, you are not going to have this here. So for me, all of us are going to do the whole assignment that we're going to do. So I'm going to do my own, you're going to do your own. So when you finish this, then I want you to go ahead and get this done like this. You plot the visual of them. So I'm going to share the frame of it. Then another thing I want you to do is that I want you to compare some point, either by clicking on them to check the variation between them, or if you don't want to click them that way, you go to geoprocessing here. You go to geoprocessing here. So I'm going to step a bit backward, and here I'm going to data management tools, the tools I used last time in creating the fishnet. So I'll go to data management tools, and I'm going to go to sampling here, and under here I can create a random point. So this is creating a random point. Now in creating a random point here, I'm going to say this is the location. What is the output name? I'm going to say random here, and what is the specification? The constraint class you are looking at is district selection, because I'm interested in the district selection. Now, how many number do you want to create here? In this way, do you need it as a feed or long? So you can leave it on long. On linear unit, which do you have a feed? No. What it? So I want to make it in decimal here. So I'm going to make it in matrix. So I'm going to put it in. First and foremost, before I do that, I might choose to know what is the distance between one point or the other, so which I can use this to measure. So I can calculate from here to here to see what is the difference between them. So if you look here, you see that I click on this. I just wanted to know what is the distance between this point, for example. So if I want to know the distance, so I can use this to carry the measurement to know approximately what is the distance between the point. So I will know what I want to use. But nevertheless, you can see here that I have the total of 338 point something meter. That means I have up to kilometer. So in that way, you can see the output of what I have here, because I wanted to check the distance between them. So I don't need that. I just wanted to know approximately the distance. So in that way, I'm going to return I'm going to return back to the geoprocessing where I am, because that's where my interest is. So return back to the geoprocessing, and then I have seen that it is in kilometer. So I can choose that the linear measurement I need to use here is that I need to use kilometer. So approximately I need the minimum allowed minimum. So I need to put 1 kilometer. So every point you are going to give me, it should be within 1 kilometer. So I will go ahead and run this. This is a random point that I'm creating. I just want to create a random point within here. So if you look here, you can see here that I have this number of points. This is the random point I created, scattered all over this place. So I don't know how many it is, but let me check to see in the attribute table to see how many points it is. Now in the point here, I have about 100 points. Ooh, that's much. Yeah, I think when I was doing the fishnet random, let me rerun it again, because that's much. So here I said the number of points, no, so I'm just going to make like 20 points to make this here. So I can increase this into 1.5. So you are going to do your own based on the district you choose. So for me, let me rerun it again. This is much for me. So in 15 points, I think 15 points should be enough for me. So I'm going to right click and press Ctrl T to see the attribute information. So you can see here I have 20 points. So this is my own point, that is 20 points. Now in this 20 points, what I'm going to do is that I'll go here, I'll close this, I don't need this. So I've already added my own 20 points here. So in this 20 points, what I want to do is I want to make a comparison using these 20 points to see the difference that happen on each of these points over the years, like over the 10 years, what like each of the points I selected. So for you, I'm making my own random. You can place your own where you want to monitor, or the same random, the same way I make my own. So you can see all of them here. So once this is done, you go to geoprocessing as well. So return back to geoprocessing, because I don't need it as I need it as a point. So you can put it 0.1, 0.2, 0.3, 0.4 to 0.20. Now return back to this same position under extraction. Go back to spatial analysis tools, go to extraction, and spatial analysis tools, go to extraction, and you say extract value to point. So I'm going to use extract multiple value to point. On this way, I want to get multiple value of this. So what you're going to do here is I'm going to enter the random point. That's the point I want to use. And then which raster do you want to use? Well, I can use the raster name as NDVI 215. Then I can also use NDVI, NDWI, and I can use NDWI for 2025. Now, I have my own here. I'm just going to run this because I'm still going to download for 2015 because I'm using 2025. I will download again for 2015 to do the same thing, so that I'm going to extract all of them all. Now, in this way, you see it here. So for the sake of this, I'm going to stop here. I'm going to click on bilinear interpolation. So because I need it to get it in points, like using this, so I'll click on this, and this is the output here. So on this case, I'm going to click on run, and then I'm going to run this particular value here. So you can see it here, and once this is done, if you click on Ctrl T, and then you will be able to have the value for each of them. So the same thing for 215, I'm going to have for 215 for NDVI and then 225 for both of them. I am going to make a comparison on these 2 points. So when I'm done with this, I will pick up this particular code values, and I will go to Python to visualize them. So you are going to use Python to visualize your own the comparison between the 2 years of your choice. Whichever way you want to do it is left for you. But for me, I'm going to use this. I'm going to give you this as a guideline. So for me, I want you to compare it whichever way you want to compare it. So I will need to see the whole point as well as the longitude and latitude in this. And then I will also need to see the whole point up like this. And then you can make your comparison of these 20 points the way you want to compare them. That's left for you. But we need to get it here. Now, how do you get the coordinate? Because I will also want you to show me the coordinate of the locations of where you get. Now, to get the coordinate, remember I've done this before, but I will repeat that. Then still go to geoprocessing here. Then when you get to geoprocessing, then return back here, go down to data management tools here, and then you go to feature here, open the feature, then you see here under feature, you will see add X and Y. Which value you want to enter X and Y? I want to add it in random and run it. And when you add that to X and Y, so you will be able to have the longitude and latitude of that point. So you see here, this is the longitude and latitude of the point. So you can see X and Y here, latitude and longitude. So in that one, I need the X, I need the Y, I need all these values, and I need the visualization and the interpretation based on these environmental changes that happen here. So you look at the district you pick. Like for me, I've already picked Bugesera. So if I'm analyzing here, I'll be able to say that if the NDVI change, it should be as a result of the airport here, because there is a new construction of airport that was not there in 2015, and this is why there is changes on the environment here as related to this. So this is where we're going to stop for now. You can go ahead and ask your question. So every other thing you are going to do as related to this are based on what we have been doing, like putting it in frame, laying them out the proper way supposed to be laid. All are going to be done in that pattern. So this is pretty much of it, and this is how we can manage the different other environmental indices. So like I said, so if you look at what I shared with you before, like if you look at what I showed with you when we were downloading on the Sentinel Hub, you will remember what I said about those indices that I showed you how you can see NDVI and other indices. So if you look here, these are remote sensing indices. You can see NDVI, you can see EVI, you can see the formula here, you can see soil adjusted vegetation index SAV, you can see NDVI, you can use modified normalized different water index, you can see normalized different built up area, assuming you are studying urban area changes, you can see snow, you can see burn area index, you can also see atmospheric resistance vegetation index, you can see leaf area index. So these are different environmental indices. There are many of them that can be used for different purposes. Like if you are looking for soil adjusted, this is designed to reduce the soil brightness in vegetation analysis, critically for studying arid and semi-arid region whereby soil is frequently visible. If you look at EVI, you also need to know why you use EVI. So there are different environmental indices or ecological indices that can be used. But for now, we just want to get to those things so you can expand your get to know difference between them and what you need to analyze as related to that. Remember, like I said, in NDVI, we use NDVI to monitor the vegetation index. Like Rwanda, you are very good in agriculture. You can see that you can use that to monitor the agricultural area to see what changes that happen. Like for example here,